This is day 10 of Advent of Code, and the challenge is called Cathode-Ray Tube. You avoid the rope, plunge into the river, and swim to shore. The elves yell something about meeting back up with them upriver, but the river is too loud to tell exactly what they're saying. They finish crossing the bridge and disappear from view. Situations like this must be why the elves prioritize getting the communication system on your handheld device working. You pull it out of your pack, but the amount of water slowly draining from a big crack in its screen tells you it probably won't be of much immediate use. Unless, that is, you can design a replacement for the device's video system. It seems to be some kind of cathode-ray tube screen and simple CPU that are both driven by a precise clock circuit. The clock circuit ticks at a constant rate, each tick is called a cycle. Start by figuring out the signal being sent by the CPU. The CPU has a single register, X, which starts with the value 1. It supports only 2 instructions. ADDX-V takes 2 cycles to complete. After 2 cycles, the X register is increased by the value V. V can be negative. No-op takes 1 cycle to complete. It has no other effect. The CPU uses these instructions in a program, your puzzle input, to somehow tell the screen what to draw. Consider the following small program. No-op, ADDX-3, ADDX-5. Sorry, no-op, 1 cycle, ADDX, this is 2 cycles, and it'll increase by 4, so it'll be 3, so it'll be 4. ADDX-5, 2 cycles, and they'll make a -1, sorry, 5 cycles and -1. Maybe you can learn something by looking at the value of the X register throughout execution. For now, consider the signal strength. The cycle number multiplied by the value of the X register during the 20th cycle, and every 40 cycles after that, that is during the 20th, 60th, etc. For example, consider this large program. The interesting signal strengths can be determined as follows. During the 20th cycle, register X has a value 21, so the signal strength is 20 times 21, which is 420. The 20th cycle occurs in the middle of the second add X -1, so the value of the register X is the starting value 1 plus all of the other ADDX values up to that point. Okay, that makes sense. Let's grab our puzzle input, and we'll start off with for each var instruction in input, we'll have int cycles equals 0. We will do if instruction equals no-op cycles ++ continue. Otherwise it'll be int num equals instruction dot split by space, and we want the number from that, so the first index 1. Okay, so we're needing to put in a check at some point for when it's cycle 20 and then 40, 80, etc. So where should that go? We also have int, what's it called here? Int register X equals 1. We'll also have outside of this, oh no, these should be outside the for loop. We'll have an int signal sum equals 0. We'll have a function called int total signal strength. Actually, no, we'll change that to sum signal strength, and we will pass it int cycles, int register X, and int signal sum. We'll do if cycles equals 20 or cycles modulus 40 equals 0. We will return register X. Actually, is it? Okay. We will return register X times cycles. Otherwise, return 0. So we'll do ++ cycles. In here we'll do signal sum plus equals cycles register X. And for here we'll do for int I equals 0, I is less than 2, I ++. We will do if I equals 1, we will register X plus equals instruction. And then at the bottom here we will do signal plus equals. Okay, let's run that and see if it works. Cannot convert string to int. Line 25. Yep. Convert dot to int 32. Now let's go. Okay, well I forgot to actually print out console dot write line signal sum. Now let's go. Okay, 6,420. Let's see if that is correct. I feel like it won't be, but let's see. Yeah, but that's not correct. Let's do a side by side to see what's going on. So no-op, do plus equals signal, carry on. Oh, we forgot to do the plus cycles here. It should be right there. Okay, now let's run it. Now let's see if this one's correct. Nope, still not correct. Okay, actually what we'll do is we'll also pass in string command. We will put this inside the loop like this. Console.writeLine, the command. We'll start off with the cycle we're on, and then do that. So down here, we'll just pass an instruction. Actually, I should call that instruction here as well. Okay, let's run it. Oh, whoops. Now let's run it. Okay, let's look at the input file again. So line 20, yep, that is correct. And it is going 20, 40, 80, 120, like that. Okay, I just realized there's actually -4 here. For a second I thought I misdid the cycles, but -4 is here. So let's count this. 1, 2, 3, 4, 5, 6, 7. That's 14, 15, 16, 17, 18, 19, 20 here. Okay, I've misunderstood how it works. It's 20 and then 40 after that. Okay, I need to change this to if cycles -20 modulus 40 equals 0. Okay, now let's give this a shot. Okay, we've now got a different number, but it's now doing the correct cycle times. So let's put that in. Still wrong. Okay, we're gonna grab this test one and see what it produces. Okay, let's run the test data. So 20 is -1, -3. Okay, but we also need to look at what number is being produced. Okay, now let's run that. Okay, so 420 was correct. This is correct. This is correct. This is correct. This is correct. But then I got it wrong here. Maybe the issue is that we're adding the number here. Maybe it needs to be after it, or here. That might be where it needs to go. Okay, we'll try here then. Okay, there we go. Now we've got the correct number. Okay, let's change this back to our normal input. Let's run it. Okay, 16,480. There we go. That's part 1 complete. Now let's do part 2. It seems like the X register controls the horizontal position of a sprite. Specifically, the sprite is 3 pixels wide, and the X register sets the horizontal position of the middle of the sprite. In this system, there is no such thing as vertical position. If the sprite's horizontal position puts its pixels where the CRT is currently drawing, then those pixels will be drawn. You count the pixels on the CRT, 40 wide and 6 high. This CRT screen draws the top row of pixels left to right, then the row below that, and so on. The leftmost pixel in each row is in position 0, the rightmost pixel in each row is in position 39. Like the CPU, the CRT is closely tied to the clock circuit. The CRT draws a single pixel during each cycle, representing each pixel of the screen as a hash. Here are the cycles during which the first and last pixels in each row are drawn. Okay, so it starts off cycle 1, and then cycle 40 is the last one in each row, and so on. So by carefully timing the CPU instruction and the CRT drawing operations, you should be able to determine whether the sprite is visible the instant each pixel is drawn. If the sprite is positioned such that one of its 3 pixels is the pixel currently being drawn, the screen produces a lit pixel. Otherwise, the screen leaves the pixel dark. The first few pixels from the large example above are drawn as follows. So the position of the sprite is here. Because it's in there, it's being drawn. Yeah. Okay, let's give this a shot. What 8 capital letters appear? Interesting. So we'll copy the existing code and we'll place it into here. So instead of signal sum, we will have var CRT screen equals list of strings. We will have string array of 6 and 40. So we'll still have the cycles. Register X is the position, starts at 1 and it's +3. Create a quick little int array get sprite position, and we'll just return new int of which contains register X +1 and +2. So for each var instruction it'll be the same thing where plus signal. You don't need signal sum anymore. We'll stay like this. We're going to create a function for draw CRT, which will take int cycles and the string array of CRT screen. So we'll have var character equals CRT screen dot contains. Oh, wait, no, this is array dot contains cycles. If it does contain, it'll be a hash, otherwise a dot CRT screen. This will, so cycles divided by 40, and then cycles modulus 40. I think that's the correct number. Probably should just print that out to begin with. Okay, so we'll have draw CRT here, and we will have that here. So when it goes through, at the end we want to, for each var row in CRT screen, console dot write line string dot join CRT row. So let's run that and see what it does. Okay, array does not contain definition for contains. Okay, let's look that up. Okay, exists might be what we're looking for. Line 49. Only assignment call increment weight can be used as a statement. Line 51. Ah, whoops. Equals character. Then line 64. Okay, well this is the value that it is. No, my bad, forgot. Join it by nothing. Array size cannot be specified. Okay. Maybe we do need the asterisk in here. Line 46. How do you define the argument type array exists cannot be inferred from usage. Try specifying the argument types explicitly. C# if value is in array. Okay, fine, we'll just use link and do contains. Wait, what was I doing here? This is completely wrong. This one was meant to do. Okay. Hopefully that fixed it. Let's run it. Line 53. Wrong number of indices inside. Oh, is it meant to be like this? Okay, there we go, but no more errors, but I've got to change this to part 2, so now let's run it. So I got up to here. So do we do if cycles equals 6 times 40 break? This minus 1 then break. Okay, let's do that. Still did it. Okay, we'll put this at the very top. Okay, didn't print anything. Had a feeling that could occur. So we'll need to change this to return this, and then we will return CRT screen, and where we call that, we'll do the value like this. Is it not adding any values to it? What's going on? Fine, we'll do for loop. Okay, hopefully that is correct now. Let's see. Wrong number of indices and forgot to do the same thing again. Okay, do that. Let's go. Oh, that's not very useful. Okay, let's go back to the test one. Okay, it might be that. Okay, let's change this. We'll also put in cycle. This inside here, we will do register x plus equals cycle be cycle divided by 40. Because it's an int, we'll remove the decimal place, so we'll just do times 40. Let's see what this does. Okay, that's progress, I guess. I think for this it needs to draw to screen before we do that. Now let's run it. Nope, that's the exact same. Actually, for this we might be able to change this to 0 and then run it. Okay, there we go. That looks correct. Let's change to the normal input and see if it works. Oh, it did work. And we have the characters PLEFULPB. Okay, well that is day 10 of Advent of Code completed. If you like the video, make sure to like and subscribe.